Hi students, in this video I am going to discuss Mesomeric Effect. This is third electronic effects in our channel. First two electronic effects, inductive effect, hyperconjugation, those two are permanent effects. Even this one also permanent effect. Okay, so those two videos already I have uploaded. 4 videos totally I have uploaded electronic effects, and then this is fifth video. Mesomeric effect, also call it as resonance effect. Okay, see what is the phenomenon? Phenomenon of possibility to exhibit more than one structure. In our textbooks, generally we are observing benzene ring, we are writing alternate to double bonds like this between these two carbons, and here like this, left to right double bonds rotation we have shown here. But here it started here double bond, and next alternate to double bond, alternate to double bond. Both are same. You may write like this, you may write like this, both are correct. Why getting like this? What is the reason? What is the reason means this is because of resonance. Because of resonance. See, so pi electrons here movement. Pi electrons is and electronic effects. What is the disturbances caused by either sigma electrons and pi electrons? But here mesomeric effect pi electrons. See this pi electrons cloud rotating, evolving nucleus, rotating around the benzene nucleus. It is revolving here. It is what is this? It is shifting to here. Then what happened between this carbon and this carbon? Now get 5 bonds. 5 bonds he can't bear immediately. This carbon, especially this carbon, get 5 bonds once shifted here. So every carbon have one hydrogen, right students? One hydrogen, and every carbon has hydrogen. See, imagine once this pi electron shifted here, double bond. This carbon you can count 1, 2, 3, 4, new bond, 5 bonds. 5 bonds means he can't bear. Immediately this pi electron shifts here. And then this carbon facing problem, immediately this pi electron shifts here. Such a way we are getting the double bonds like this, shifting here, after that shifting here, after that shifting here. So due to what is that? Due to pi electrons transfer. Due to pi electrons transfer, we are getting another structure. This one, this concept only we call it as resonance effect. Resonance effect. Okay, you may write like this benzene structure, you may write like this also, or else instead of this we are writing one more also. The pi electron revolving around the nucleus, just you can write cycle also. All are same. Okay, this concept explained by the resonance. See, first point students, I have written some rules here. So characteristics and rules of writing resonating structure. First one, atomic rearrangements not possible. See students, here 6 carbons we have. I am not disturbing atoms. Where is the carbon? One place, same thing. I am not disturbing the carbons. I am not disturbing the atoms. So only pi electron shifting, only electronic rearrangements possible, only electronic rearrangement possible. Now next point. See, third point, this plays very important role. So finally, mesomeric effect, resonance effect, I am making 3 videos students. 3 videos, and already I have uploaded OP directors, meta directors, most important concepts. Those also I can attach in this video only. I can attach a description box I will give. So please go through all the points. Definitely you'll get good command in organic chemistry, mesomeric effect questions. Now see, third one, electron displacement is possible. Electron displacement is possible with respect to pi bonds. Just now we have taken pi bonds. Next lone pairs, negative charge. Next positive charge. And what is this? One more point. And odd electron. Odd electron also it can show. What is the combinations? 5 combinations. Pi lone pair, pi negative charge, pi positive charge, pi odd electron, like this. I will show each and every example, then you can understand more better. And important point is here only pi electrons, not sigma bond, sigma electrons. Okay, and it is permanent effect students. This one also permanent effect. Permanent effect. Okay, now next one. All possible structures call it as resonating structures. I will show all possible structures we call it as resonating structures. How many possibilities is there? We can write all structures we call it as resonating structures. So now next one. Next one. What is the next important point? Yes, this is most important point. See, due to resonance in benzene, no CC bond, no C double bond C bonds. All CC bond lengths are equal. All CC bond lengths are equal. Look into the students' benzene structure. It has single bonds and alternative double bonds. Actually, CC single bond compound showing bond length 1.54 angstroms. C double bond C showing 1.34 angstroms. But benzene it is showing 1.39. It is lies between CC single bond length and C double bond C. Reason behind this, it is in conjugation. So it is in conjugation. See, all 6 carbons are in same plane. sp2 hybridization, sp2 carbons are sp2 hybridization, all are in same plane. All are in same plane. All bond lengths are equal. All bond lengths are equal due to resonance. Due to resonance. This is one of the most important question. CC single bonds means it show 1.54, but it did 1.34 C double bond C, but it is showing 1.39 means it is having both the bonds, single and double bond, that too in resonance. Okay. Now next one, benzene is stabilized by resonance. How much? How many calories, students? 36 kilocalories per mole. 36 kilocalories per mole. So that is why benzene gives substitution reactions rather than addition reactions. See students, one important point I am telling. So benzene, it has 3 double bonds. Pi bond. We have sigma bond, pi bond. Which is weak bond? Pi bond is weak bond. So easily we can break and add maybe hydrogen, maybe chlorine, anything we can add. We expected more addition reactions. Addition reactions is nothing but breaking old bonds, making new bonds. Breaking here, and we can add addition, add chlorine or else anything, chlorine something we are adding. But it is not possible. Addition reactions are not possible. Instead of addition reactions, rather than addition reactions, it shows more substitution reaction. Why? Because it is stabilized by resonance. It is stabilized by resonance. Already it is in stable condition. Already it is in stable condition due to this moment, due to this pi electrons conjugation, it is stable. That's why it, rather than addition reaction, it will undergo substitution reaction. Okay, these are main important characteristics which is frequently asking in examination. Okay, next I have written types. Types of resonating structures. Resonance possible in 5 systems. Pi conjugation. Just now we have shown. Just now we have seen what is the students? Benzene. So this pi electrons movement here, this pi electrons movement here, this pi electrons movement here. Finally, what we are getting? This is structure. Due to pi conjugation. Pi lone pair. I will show each and every example. Pi lone pair. What is a lone pair, students? What is a lone pair? Lone pair is nothing but, so like this, pi lone pair. If pi lone pair is there, that is also show conjugation. Pi negative charge. Negative charge is there, that is also it shows conjugation. And pi positive charge, it is there, it is also shows conjugation. Pi odd electron is nothing but free radical. So these are all conditions time, definitely it can show resonance. Okay, now pi conjugation already I have showed. So benzene example. Next, pi lone pair combination I am showing here, students. Listen, pi lone pair, you can write the points. Pi lone pair in conjugation. Pi conjugation is nothing but benzene only. Starting also I had explained and here also I have shown. So enough that one, pi lone pair. Now look into this, CH2 double bond. Okay, CH, Cl. Chlorine has lone pair of electrons, right? They will not give lone pairs and all. You are in a position to identify. So we have studied already valence electrons, Lewis dot structures, all we have studied. You people know. Chlorine has 6 lone pair electrons, 3 lone pair sets. Now this is C condition, pi bond lone pair, pi bond lone pair. It is in conjugation. E is electron rich. C, which is having lone pair of electrons acts as nucleophile electron rich species we have discussed in the previous videos, right? So this pi electron movement here moves here. It is in conjugation. It is in conjugation. See, he is transfer here, lone pair transfer here. Once transferred here, imagine students here, this carbon, already how many bonds? 4 bonds. 1, 2, 3, 4. 4 bonds is there. Now new bond, electrons is nothing but 2 electrons coming is nothing but bond. 2 electrons coming is nothing but bond. So now new bond, 5 bonds. 5 bonds this carbon can't bear. Immediately this pi electron shifts here. So then what you will get here, students? What you will get? CH2. He is taking electrons, means this carbon negative charge, and CH double bond Cl. Okay, chlorine gets positive charge. Chlorine has given. Remaining 2 lone pair sets you can write as it is. Clear? Only 1 lone pair shifted, that is 2 electrons. How we are showing? In terms of bond we are showing. Clear? This is pi lone pair conjugation. Pi lone pair conjugation. And finally chlorine got positive charge because he had given electrons, and here carbon got negative charge because he has taken. It is in conjugation, right? Next one more is there. What is this? Very important one. This is NH2 group. NH2 group. See, this is also pi lone pair. Pi lone pair. This is aniline, students. This is aniline. Pi lone pair in conjugation. See here. This is lone pair of electrons ready to give electrons to the system. Benzene ring ready to take, ready to give. Depends on the partner. Like this. Then what happened? Look into this. Double bond, new bond has come, double bond NH2. So in this carbon now got double bond. If it is not shifting this pi electrons for this carbon, otherwise it will get 5 bonds can't bear. Then immediately what happens, students? As it is these two you can write. And what is this? This bond, negative charge. That's it. Clear my point? This lone pair given to here. Once lone pair taken, this carbon now got 5 bonds. 5 bonds he can't bear. Immediately this pi electrons between this carbon, pi bond is there. The pi electron shifts to this carbon. Now carbon has taken means negative charge. Who has given your nitrogen has given positive charge. Like this. Now next what happened? This negative charge unstable. Positive charge also unstable. Next try to take or else try to give electrons. Electron rich means it will give it to electrons to next guy and get stabilized. He will give it to negative charge here and this pi electron shifts here. Then what you will get? NH2 plus, this is what, students? Here this negative charge comes here. That means negative charge is nothing but bond only. Negative charge is taken charge. Taken charge is nothing but negative charge is bond only. Now immediately they push here. That's it. Clear? Now next one. Now this one shifting here. This one shifting here. Now what you will get? NH2 plus. Okay. Now he has taken negative charge here. Bond here, bond. So finally this is another structure. Next last step, what happens? See, this pi electrons shifting here, this negative charge shifting here, negative charge shifting here, this pi bond going back. Look into this. 1, 2, 3. NH2 finally he has taken lone pair electrons as it is. Bond is nothing but 2 electrons. 2 electrons you can write like this. Clear? What is the difference between these two structures, students? Observe carefully. What is this difference between these two structures? I did not change atoms. Has not changed any atoms. How many carbons are there? Same number of carbons, same positions. The NH2 also same. I was not disturbed. What I disturbed here? What is the disturbance causes here? Pi electron. See here like this. Between these two carbon double bond is there like this. But here like this. Left to right. Here right to left. That is the difference. This is we call it as resonance. Due to pi electrons disturbance, these many resonating structures. These structures we call it as resonating structures. I said one point, above point what I said, all possible structures are called resonating structures or canonical structures. These are resonating structures. More resonating structures, more stable, like that. More resonating structures, more stable. Clear, students? Now next one. Next, pi lone pair completed. Now I am taking third one, pi and negative charge. Pi and negative charge combination. Negative charge conjugation. Pi and negative charge conjugation. Look into this. Pi bond. So write down CH2 double bond, CH2 double bond, CH2 minus. Okay. Now he is in conjugation. See, pi bond and negative charge. Negative charge electron rich species. He is ready to give electrons here. Once he shifted here, this carbon now get 5 bonds. 5 bonds he can't bear. Then immediately shifted here. Then what happened? CH2. This has taken bond. Taken bond means electrons. Next one, CH double bond CH2. See, both are same structures. Both are same structures. Here negative charge, got it? Here shifting here. This is pi and negative charge in conjugation. Pi and negative charge combination. Here also one negative charge is there, one double bond is there. Here also one negative charge is there, one double bond is there. Or equal contributing structures, equal resonating structures. Okay. Now next one, pi positive charge. Pi and positive charge conjugation. Pi positive charge conjugation. So we look into this. Pi positive charge conjugation. So now see, what is this? CH2 double bond. Instead of above case plus charge, you can take it instead of negative charge. What is this? CH2 plus. CH2 plus. You can observe one more point. Around carbon it should be 4 bonds, right? 1, 2, 3. So one bond is less. That's why positive charge. Instead of one bond, negative charge, like that. Now see, students, this is positive charge is nothing but electron deficient. He is not having sufficient electrons. He will take electrons from someone. Once given here, this carbon now will get 5 bonds, right? 5 bonds. Then he can't bear. Immediately, what happened, students? What happened? Look into this. CH2. He had given positive charge. Next, what happened? CH double bond CH2. That's it. Clear? See, he had given electrons. This carbon got positive charge given to here. So then this negative charge, this negative charge he is taking means negative charge, positive charge nullify, or else this positive charge you can. Finally, what you observed here, one double bond positive charge, double bond positive charge. This is pi positive charge combination. Pi positive charge combination. Okay, here negative charge means electron rich, he is ready to give and satisfy, stabilize, and positive charge means he will take from someone and get stabilized. So pi negative charge also it is in conjugation, pi positive charge also it is in conjugation. Is it clear, students? Now one more last point. What is that? Pi odd electron in conjugation. Pi odd electron. Pi and odd electron in conjugation. Pi odd electron in conjugation. Can you write now, students? What is this? Pi bond CH2 double bond. Okay. Instead of negative charge, you people can write positive charge. You can write odd electron. That's it. Free radical. Only one electron is there. 2 electrons is there. Then only bond. It is also unstable condition. He will take electrons. That's it. Now he will write. He has given means he will get now dot. CH double bond CH2. That's it. Even what is the difference here? Here this carbon having double bond, this carbon having odd electron. Now ulta. This is odd electron here, double bond here. This is what we call it as resonating structures. Resonating structures. And we are going to discuss plus M groups and minus M groups also, students. All plus M groups and minus M groups. I will give the link also. So that link, please, along with this you have to listen that link points also. Definitely you will get good command. Okay, first I will show here plus M groups and minus M groups. So positive in mesomeric effect we have two types. Mesomeric effect, two types. Resonance effect or mesomeric effect. Two types. What is the two types? What are those two types, students? One is plus M group, another one is minus M. Instead of plus M you can write plus R also, because it is also called as resonance effect. That's it. Now look into this. Who is taking electrons and who is giving electrons plays important role. Nitrogen having lone pair of electrons. Nitrogen having lone pair of electrons. He is ready to give it to benzene ring. Such a way, this group what we call it as plus M group. Plus M group. That's it. Now, if you have taken example like phenol, OH is there. OH is there. So this is ready to give electrons. This is also plus M group. Like this. Finally, plus M groups is nothing but giving electrons to the benzene ring. Benzene ring acts as both. It ready to take, ready to give. Depends on the partner. So he is taking, withdrawing, electron withdrawing. This is electron giving is nothing but electron releasing groups. Proper word is electron releasing. Electron withdrawing from benzene ring. Which is deficient, definitely he will take. Now to understand more better, I am giving one example. Look into this. Yes, most of the students they will confuse here. N double bond O. This is nitrobenzene. It has lone pair, but this is minus M group. See students, first case nitrogen has lone pair. You are saying it is plus M group, right? But here nitrogen also having lone pair. But why don't you say it is plus M group? Why are you saying minus M group? Look into this. Look into this point. Compared to nitrogen and oxygen, who is more electronegative? Oxygen is most electronegative element. This pi electron shifts towards oxygen side. Such a way, he will get negative charge. He will get positive charge. He'll get positive charge, right or not? So once he got positive charge, now he is deficient. This lone pair electrons shifted here, or else this pi electron towards oxygen side. Such a way he will get positive charge. Positive charge means deficient, right or not? Deficient means he will take electrons from benzene ring. This case, no one is taking. He is giving to benzene ring directly. Directly it is giving. So that's why you call it as it is plus M group. But here it is there, nitrogen has lone pair of electrons, there is no doubt. But the dominating one is oxygen. Oxygen is attracting electrons towards itself. Such a way he will get negative charge, he will get positive charge. Positive charge which is directly attached to benzene ring element definitely is electron deficient, right? Electron deficient means he will take electrons now. He will take electrons. Taking electrons means, what is this group? What is this group we call it as? Taking electrons means minus M group. That's it. What is that, students? Minus M group. Clear my point? Minus M group. So like that we have plus M groups and minus M groups. All I am going to list out now. So first write down all plus M groups. All plus M groups. NH2, lone pair of electrons it gives. Next OH, it gives. Next one SH, they will not give lone pair, students. You have to identify. Okay, OR, lone pair. Next one Cl. Next Br, bromine, it has lone pair. Next iodine also lone pair, it is also giving electrons. Next one NHR, it is having lone pair. Next one O minus, minus charge also, like this. Suppose condition is like this. O minus, what we call it as phenoxide ion. Phenol, after losing hydrogen, it gives phenoxide ion. It is also electron rich. How he got negative charge, that is not our matter. So he is giving electrons to benzene ring or not? Yes, he is giving electrons to benzene ring. Then it is plus M. Next, like selenium examples. Okay, frequently asking examples I have written here, students. Now, next one. What is this? Minus M groups. Minus M groups also I am writing here. What are the minus M groups? Which is having positive charge. NH2 plus. Next, NR2 plus. If it has positive charge, definitely takes electrons. Takes electrons means it is minus M group, plus charge. Next one, C double bond OH. This one also, most of the students confuse here. See, between carbon and oxygen, who is more electronegative? Oxygen. Pi electron shifts oxygen side, he will get negative charge, he will get positive charge, which is directly attached to benzene ring. That element have positive charge. That's it. So you can identify like this. Next one, C double bond OH. Here also same thing. So 5 electrons here, this is negative charge, this is positive charge. That's it. Now next one, C triple bond N. Here also pi electron shifts towards nitrogen side, he will get negative charge, he will get positive charge, which is directly attached to benzene ring. Positive charge, it takes electrons, minus M group. Next, most important example, nitrobenzene. Just now I showed, this is also pi electron shifts here, negative charge, he will get positive charge, which is directly attached to benzene ring. That element have positive charge means definitely it takes electrons. Then what is this? It is minus M group. Most important example. Strong electron withdrawing group. Strong electron. These are all strong electron withdrawing groups only. But among all, this is the strongest one. Next, C double bond OR. These are all minus M groups. Okay. He is also taking electrons. Plus charge, charge. That's it, students. With this we have completed introduction part and plus M groups, minus M groups. And the next video I am going to explain stability of these compounds, some other points also. Plus M effect is there, ortho para-directors, minus M group is there, why it is meta-director. I will show all the points. Thank you, students. Thanks for watching.